Today, let's talk about how to import and export data in GaussDB. Before we start, let's take a look at the tools or SQL statements we have and their related scenarios. Here are the tools and scenarios. At first, the gsql is used to import and export SQL statements and SQL text statement and is available for both centralized and distributed instance for GaussDB. And the copy to and copy from is a syntax in GaussDB used to import and export query result sets. It's available for both centralized and distributed instance GaussDB. And the GaussDump and the GaussRestore is used to import and export a large volume of data online and import and export the data object definitions. Is available for both centralized and the distributed instance for GaussDB. And the Gauss loader is used to import data online in Oracle SQL Loader compatibility scenarios. It's only available for centralized instance for GaussDB now, and will be available for distributed instance in the future. And at last, the Gauss Data Service is GDS. Is used to import and export a large volume of distributed data offline. So it is only available in GaussDB distributed instance. And this tool provides advantages of multiple data nodes to concurrently import data, which improves the import efficiency. And the corresponding Oracle import and export tools are also listed on the right side. Now let's take a further look at the gsql client tools. The gsql is used to create object definitions in text format and to import or export data. Here are the parameters you need to know. -d is the database name, and the -p is the port used to connect to a database coordinators or data nodes. And the manners U in uppercase is the username used to log in, and the manners W in uppercase is the user password, and the manners F is the SQL script file. That is the imported data file, and the data is in text format. We can rebuild and import the exported database objects and data with the manners F options. And here is an example on the right side. The exported point SQL file is shown here. When the gsql tool is used to import the file, followed by the manners F option, and the SQL script statements in this file here will be executed. We can also use following meta commands to import and export data after a database is connected using gsql. The \o is used to output all query results to a file. And when running this command, we can add the file name to output the query results to the corresponding file. And the \i is used to read the input from the file and execute it as if it had been tapped on the keyboard. And the \copy is the import and export meta command of the client side of data in tables. The data source can be a standard input or files. And the \copy command is related to the copy command, and the copy command will be mentioned later. So here, let's talk about the copy statement or copy SQL statement in GaussDB. We have seen the meta command \copy without then here the copy command without the / character has the difference. The difference between these two commands is that the command with the / can be executed both on the database server side and the client side, while the command without the / only be executed on the database server side. Copy can be used for importing and exporting a small volume of data, as well as exporting query results. Here's how we can use it. To import text data from a file to the table T1, you can run the copy T1 from the data file path here, and the connect followed by from is the corresponding file name, and the delimiter followed the file name is the field separator. To export data from the table to a file, we can run the copy to command, and the delimiter is also the field separator. We can also use this command to export the query result size. We only need to replace the table name T1 with a query SQL statement. For example, to export data that meets the A2 equal to 1 condition from the table T1 to a field, we can run copy the query statement to data path. On the right, we can find an example of exported data. The column fields are separated by commas, and the data values are clear. In distributed scenarios, the copy from and copy to is used to import and export data to and from coordinator, but the performance is not as good as the Gauss data service, which we will discuss in detail later in the part of Gauss data service. And we can use the copy from or copy to in Java database connectivity through the copy manager application program interface. First, create a copy manager object, and the meta file is the path of the data file. Use the statement copy meta file from the standard input with format CSV, and add the data file path to the file reader in method copy in. With such an API, we can then easily import or export data in the Java program. And next, let's move to the part of GaussDump and Gauss restore. The GaussDump or the Gauss restore can be used to backup and restore objects, definitions of a database logically. We can choose to export a whole database or certain objects in it. The objects will include schemas, tables, views, and etc. The GaussDump or Gauss restore can also be used to import and export in off-circle statement. The point circle fields are imported and exported in plain text format. We advise that do not use GaussDump and Gauss restore in the peak hour for database applications. And when GaussDump is used to export data, other users can still access the database, so the database service will not be affected. Here is how we can use the GaussDump tools in GaussDB. We can run GaussDump mydb -u -w -p -s -t -f to export definitions of a single table. The parameter descriptions are as follows. The -u in uppercase is the username used to log in, and the -w is the database user password. The -p is the port used to connect to a database coordinators, and the -s means only object definitions are exported. And the -f in lowercase is the field that output will be written to. And the -f in uppercase is the format of the exported file, which can be a plain text and a custom archive, a directory archive, or a tar archive. When we export a file in plain text format, we can easily import the data to the database using the tool gsql. However, if the file is in custom archive, directory archive, or tar archive format, we need to use the tool Gauss restore to restore it to the database. And in the right side is an example of a file in the plain text format. And to export all object definitions of a database, we do not add the manners_t parameter. And we use the manners_s and manners_f parameters only. And if we need to export data in tables, we need to remove the manners_s parameter. Next, let me explain how to use the GaussRestore tool. The GaussRestore is used together with the GaussDump. A field exported using GaussDump can be in plaintext format and other 3 formats. We can use the gsql to import fields in plaintext format in the right side, and we can use the GaussRestore to restore fields in these other 3 formats to the database on the right side. Here are some differences between the 2 import methods. If we use gsql, it's hard to shooting the arrows during the import. But however, if we use the GaussRestore tool, it will promptly notify us any errors and where they occurred. If we need to modify the backup field, we can using the plaintext format, and the gsql is more friendly. Next, let's talk about the Gauss loader. Gauss loader is a data import tool, and its syntax is compatible with the Oracle SQL Loader. It can be used in several scenarios. First is the Oracle SQL Loader compatibility scenario. In Oracle, data can be imported using SQL Loader, and then data was migrated to GaussDB. Gauss Loader can be used to import data. So the fault-tolerant scenarios is necessary. With the parameter errors, tolerance can be performed for the error data during the data import. And so for the principle of the Gauss loader, it was built based on a \copy method command and has been enhanced to provide the import compatibility. Now let's talk about how to use the Gauss loader. First, we need to create a user and grant the user the required schema or the table permission. Is the first step. Next, we need to use the copy summary create functions to create the summary table, and we use the copy error log create to create the error table. The Gauss copy summary table records the execution result summary, including how many successful rows, error rows, ignored rows, and empty rows there are. The pgexit copy error log records the error tolerance information, including the number of each line and other information. On the right side, here is an example of the Gauss loader control field. We'll talk about it in detail later. Here's an example of a data field. It's a regularly comma-separated value field. Values are separated by comma. When all things are prepared, run the Gauss loader command to import data. Let's focus on some key parameters in the command line here. The control is the control syntax field, and the data is the data field. The discard is the name of the field recording the rows that fail to match the when condition. We can also specify a directory to generate the field based on the data field name. And similarly, the bed is the name of the field that records the error rows. And we can also specify a directory to generate the field based on the data field name. Errors is the maximum number of error rows in a data field. If the number of error lines exceeds this value, the import text will fail and roll back. And here is the execution result of the Gauss loader. And now let's take a further look at the syntax of a control field. It always starts with the load data, and the SQL loader table here is the target table name, and the truncate is a loading method, which deletes any existing data from the table before importing new data. And other loading methods available are insert append, and replace. The fields terminated by the comma indicates that fields in the data field are separated by comma. And the when name equal to Jack indicates that data is filtered by name and only data whose name is Jack is imported. The imported field and the definitions in the brackets here. The ID is the field name and the integer external is the field type. In Gauss Loader, it supports two types of data, the portable data types and the non-portable data types. These two types are similar to those of the data types in Oracle SQL Loader. Now let's process the features of the Gauss Loader. First is the position, and this feature enables us to obtain a field based on its actual position. To use this feature, we can add the position statement to the end of the field. In the example below, the first four characters are digits, and if you specify position 1 to 4 for the column ID, the value of ID will be read as 1001. Similarly, if we specify position 5 to 6 for the column name, the value of name will be read as AA. The import result is the same as that on the right. The second further feature is the column expressions. You can add the trim function to the end of a field as an expression. This will remove the null character from both sides of the field. You can also add other expressions such as replace. Here's an example. In the three column, each field value contains a colon here. And by adding a replace expression at the end of field in the control field, we can convert the colon into a short line. Here, the import result is the same as that on the right. And the third feature of the Gauss loader is to commit by rows. You can use the rows parameters to specify how many rows of the data will be imported before a commit is triggered. If we need to import a data field with 10,000 rows, we can set rows parameters to 1,000, which means a transaction is committed after every successfully import of 1,000 rows of data. So if the first 9,000 rows are imported successfully, but the 9,001 rows failed, the first 9,000 rows of data will not be rollback. So here is the best practice of the rows parameter that do not add more than 1,000 commits in a single import, or the performance may suffer. Finally, let me introduce the Gauss data service. The Gauss data service is used to quickly import and export a large volume of data in distributed scenarios. The data nodes are used to concurrently import and export data, and multiple threads of the Gauss data service process are also used to concurrently import data, so which improves the performance of the data import. We can use the Gauss data service to import data from text fields to large tables and export data from large tables in distributed scenarios for GaussDB. It is recommended that these tools to be used to import or export data offline. Now let's talk about the principles of the Gauss data service. The traditional way we use to import data on a single node is inefficient. So the Gauss data service fully leverages the parallel imports of multiple nodes to improve the efficiency. During the import, coordinators only plan and distributed the data import task to the data nodes so that the results of the coordinators can be used for other tasks. The Gauss data service process read and split the data fields here, and the distributed data blocks to the data nodes. The data nodes then parse the data, calculate the hash value based on the distribution keys in the table, and determine which data nodes a data record belongs to. If a data node determines a data record belongs to itself, the record will be cached locally. Otherwise, the record will be sent to the data node that it actually belongs to. A cluster can be connected to multiple Gauss data service at the same time to import data, and each Gauss data service can map to multiple foreign tables to import different data files. Here's the foreign tables. Multiple data nodes and the Gauss data service can work together to improve the import efficiency. When using the Gauss data service, we need to use the foreign tables. A foreign table identifies the location and format of the source data file, but it doesn't store any data. Here is how we can use the Gauss data service. After Gauss data service is installed on a data server, we can run the Gauss data service command to start the GDS. The -d indicates the directory containing the data files to be imported, and the -p indicates the listening IP address and the port of Gauss data service. If not specified, the default IP address is 127.0.0.1, and the default Gauss data service listening port is 8098. And the managed H in uppercase indicates the GaussDB host allowed to connect to the Gauss data service. The managed I indicates the Gauss data service log file. As mentioned earlier, when using the Gauss data service, we need to create a foreign table. Here is a statement for creating a foreign table. Pay attention to some parameters, including the path of the file corresponding to the foreign table, the format of the source file, the encoding of the source file, and the delimiter. We can specify any error table name with the error table statement to save the error information. To import the data from the foreign table to the table T1, we just need to run the insert selector command here. Insert into table T1 and select from the foreign table. During the import, there may be some errors, which are recorded in the error table. Let's take a look at this error table. It includes the node ID, is the ID of a data node, and the time when error data is read into the error table, and the name of the text field containing the error data row, and the row number of the error data in the text field, and the raw record of the error data, and the error cause. Some common import errors are listed below. We usually miss the invalid backsequence for the encoding UTF-8 0x00, which means this text data containing the 0x, the null character, which is invalid for encoding UTF-8 in GaussDB, and the missing data for column A2 means that a column value is missing from the error data row, and the value too long for tab character means this field value in the error data row exceeds the field length defined in the table. And the process for exporting data is similar to the one we just talked about. For exporting data, first we start the Gauss data service, and next we create a foreign table with the read-only format, and then we run the insert into foreign table and select from the table to export data. At last, let's summarize what we have learned today. We have learned about 5 tools for importing and exporting data in GaussDB. To import or export database metadata, you can use the GaussDump or GaussRestore tool. And it can import and export data objects definitions. To import or export a small volume data, you can use copy from or copy to circle statement. It can import data from a data source to a database server, or export data from a database server to a data source. To import or export circle statement, we can use the gsql and the meta command \copy. They can import data from a client to database server, or export data from the database server to a client side. To import or export a large volume of distributed data offline, for distributed GaussDB instance, you can use the Gauss data service. It uses the multiple data nodes for parallel and to import and export. And to import data in any Oracle SQL Loader compatibility scenarios, we can use the Gauss Loader tool. Its syntax is compatible with the SQL Loader. So here we finish the course of the import and the export in GaussDB. Thank you.